All right. Okay, number 3. The idea is to prove that AC is congruent to EG. So we have this length. We're trying to show that this is congruent to this, and we have 4 triangles. So what do you think the process is going to be in general? Prove the triangles are congruent, right? Maybe not all of them, but prove certain ones are congruent. So I'm going to do this step by step. You might be able to limit the amount of steps that you have, but I'm not going to just because, just because. So what do you think the first step is? Okay. Now, I even broke that down into 2 separate statements. D is the midpoint of BF. Why? Given. Okay. If D is the midpoint of BF, what do you know? DD is congruent to DF because? Maybe this might be a good idea here. Come on, what do we do after we... Nobody knows? What do we do after we say something? What do we do with this? Mark it in the picture. Okay, so we're going to mark BD congruent to DF. So we're going to mark that. It's congruent to that, right? Okay, so we're going to mark that is congruent to that. Now what's the next step? D is the midpoint of the other one, of CE, because given. What's the reason? Or what's the next statement? CD is congruent to because okay. And we're going to mark that in the picture too. So we can say CD is congruent to DE. Can we say anything else? Because vertical angles. Okay, so angle BDC is congruent to angle EDF because vertical angle what? Theorem. Okay, so we're going to mark that in the picture. No. That just means you're going to copy down the whole proof on your little paper thing. That's not right. No. Okay. That would be cheating. All right. So what can we say about those 2 triangles now that we have that? They're congruent. So triangle BDC is congruent to, now make sure we state it right. What does B correspond with? F. What does D correspond with? D and E. What's the reason? SAS congruence. What steps?
Steps 2, 4, 5.
Okay. Now this is where checking things off becomes absolutely critical. Okay. Have we used step 1?
Yes.
Yeah, we used it to come up with step 2. Have I used step 2?
Yeah.
Yeah, where?
Step 6.
In step 6. Have I used step 3?
Yes.
Yeah, to come up with step 4. Have I used step 4? Yes, to come up with step 6. Have I used step 5? Yes, to come up with step 6. So this is a good indicator that we're on the right path. Okay? There's going to be a point where we're going to have a lot of things that aren't checked off that we'll use at the end of the proof, not right after we use them. So what do we say? After triangles are congruent, what can we say? CPCTC. What did you say? BC is congruent to EF because of CPCTC. Now our goal, now that we've proven those two triangles are congruent, our goal is going to be to prove the outer triangles are congruent. Okay? So that's why we said this is congruent to this, because those are both part of the outer triangles. So I'm going to use a different color to represent that. Okay. Can I say anything else? I can actually say, and this may not be beneficial to you right off the top, but if you look at your next given, it says AB is parallel to FG. What do parallel lines give us? Angles. So this is the only transversal that passes through both those lines. So we're going to be talking about this whole angle and this whole angle. So it would be beneficial to mark or to say that this piece is congruent to this piece for later. So we're going to say angle CBD is congruent to what? D what? DFE, okay. DFE because why? CPCTC again. Okay. So let's go ahead and mark that. And I'm going to use, well, I guess I can use 2 marks here. It's okay. Okay. Now, I use step 6 to come up with step 7 and 8. Right? Okay. Now, is this angle, are these 2 angles part of the outer triangles? No. So we've got to come up with something for those outer triangles. So, actually, I'm going to change this real fast, and you'll see why later. The measurement angle CBD equals the measurement angle DFE. Why? Definition of congruence. Okay. Now we're going to go on to, so we use step 8. We use step 8 to come up with step 9. Now we're going to go on to our next given. What's our next given to us? AB is parallel to FG because given. Okay. Well, again, parallel lines give us angles. Which angle does that give us? If this line is parallel to this line, that's the transversal. Gives us this angle, ABD, and this angle. Okay, so angle ABD is congruent to angle DFG because what kind of angles are they? Alternates interior angle theorem. Okay. So I use step 10 to come up with step 11. What can I say about this? Not yet. If these are congruent, then I can say they are equal to each other. ABD equals DFG because definition of congruence. So we can say, we use step 11. Any ideas now? See, we haven't used this statement. Can I come up with something that relates this angle to this angle? What did you subtract? Okay, but we need an equation to be able to do that. So you said like ABD minus CBD, in a way. So if we have ABD minus CBD, what would we end up with? ABC. But we want to write this in good notation, or the best, I guess the best logic. So yeah, we're going to get to there eventually, but to get to there, we have to write the angle addition postulate. So measurement ABC, what? Plus CBD equals measurement of angle ABD. What's that called? Angle addition postulate, okay. Okay. Now I can kind of plug things in a little bit. There's a CBD right there. So instead of CBD, what could go there? DFE. And so let's go ahead and write that. Measurement angle ABC plus measurement angle what? DFE equals measurement angle ABD. What's the reason? Substitution? Yep. Substitution. What steps? 9 and 13. So since I use 9 and 13, I'm going to check them off. 9 and 13. Is there anything else I can do with that? ABD and ABD. So what would that say? Okay, so ABC plus DFE equals, instead of ABD, we're going to put DFG. What's the reason? Because I replaced the whole thing over here. So transitive property, steps 12 and 14. Okay. Oh my goodness. How many steps was it? Okay. So, step 16. Any ideas now? Now you have two angles that add up to DFG.
Yes.
Can you come up with another equation with DFG in it? Yeah. So this angle addition over here. Now I want to name them the same way that I've named them in the past. So I've named DFG and DFE, right? Okay. So it's going to say measurement of angle DFE plus measurement of angle what? EFG equals measurement of angle DFG, because angle addition postulate. Okay. And that does a lot for us, actually. What do we notice about step 15 and step 16? They both equal DFG. So that means this sum equals that sum, right? So measurement of angle ABC plus measurement of angle DFE equals measurement of angle DFE plus measurement of angle EFG. Because transitive property, steps 15 and 16. So I can check those off. This is crazy. Who came up with this problem? I did, you're right. Now what could I do with that? Yeah, they both have DFE on both sides. So it would say measurement angle ABC equals measurement angle EFG, because subtraction property. Almost done with this thought. This was the longest thought process here. If ABC equals EFG, then angle ABC is congruent to angle EFG because definition of congruence, okay? And then I can do what with that? I can mark it. So now we've just shown that ABC, this angle here, is congruent to this angle here. And so how much of the outer triangles do I have in order to show triangles are congruent? So I've got an angle and a side in this triangle out here, and an angle and a side in this triangle. So what else do I need? I need another side or another angle, right? Before I do that, let's check this off. We use step 17 to come up with step 18, 18 to come up with step 19, okay? So what else could I say? A and G are both right angles, right? Okay. So actually I'm going to break that down into two separate statements also. Angle A is a right angle. Why? Given. What is a right angle? 90 degrees. So I could say measurement of angle A equals 90 degrees. Why? Definition of what? A right angle. Okay. So step 20 led to step 21. But I'm kind of stuck there, so what could I say now? Oops. Angle G is a right angle? Because given. And if angle G is a right angle, then measurement angle G equals 90 degrees because definition of right angle. So step 22 led to 23. Now what? Since A is 90 and G is 90, then what? They're the same, so what do we say? Measurement angle A equals measurement angle G because transitive property, good. Transitive property, steps 21 and 23. Okay, so I can check those off. And if they are equal, then angle A is congruent to angle G because definition of congruence. And now that I said that, I can do what? I can say the triangles are congruent. So let's mark this first. We've got a right angle here, congruent to the right angle there. So we could say that those triangles are congruent. So triangle what? Name it. ABC. Make sure things go together. ABC is congruent to what goes with A? G. What goes with B? F. Oops. E. Because? What'd you say? AAS. Congruence. What steps did I get my angle side from? Step 7 was my side. Step 19 was one of my angles. And step 25. So what was it? 7, 19, and 25. This is why it's important to put these numbers, because we're going all over the proof in order to get them. So 7, 19, and 25. 24 led to 25. So now, since those triangles are congruent, we can say AC is congruent to EG because good stuff.
Yeah, we shouldn't get points for this. Get 1 point for every 3.
Something like that. It's like thought processes. So this is like one idea. Actually, this would be like one idea, proving the first set of triangles are congruent. Then the next idea is maybe the parallel line logic, getting to these angles congruent. And then this set of logic gives me these congruent, and then that leads me to triangle congruence, and then CPCTC. But in a sense, it's like you get a third of a point for each line. Well, it's 27 steps divided by 3 gives you 9. Okay? Yeah. Yeah. Just know this proof, okay? Know this proof. Yes. What did I just say? Know this proof.
Come on, you gotta know it.
That's all I'm going to tell you.
So we gotta memorize all the steps? Yes, memorize it. It's gonna be the same order.